All right, let's look at an equation of a tangent line. All right, so we have a graph of f of x, and we want to find the equation of a tangent line at x equals a. All right, so remember that in order to come up with an equation of a line, we need a couple of pieces of information. And so especially for point slope form, oh, actually I misspelled it. There should be an E there. All right, we need a point. I'm going to call it x1, comma y1, and a slope. So that's why it's called the point slope form. So slope is m. Then once you have those two, then we know that the equation is y minus y1 is equal to m times quantity x minus x1. So piece of cake. All right, so let's do that. All right, so in this particular case, our function is f, and we need to find the two pieces of information. So let's go find that. So here, 1 and point. So we want x1, comma y1. In this case, since point of tangency is at x equals a, so x1 is going to be a. Then corresponding y value y1 would be, so this is going to touch the graph. So if you plug in a for x, you get obviously f of a. So f of a is its y coordinate, right? So we got the x1 and a y1, and we want to find the slope m. So number 2, slope m. All right, remember that the derivative contains all the information about the slope, right? So we just have to ask the derivative of the function f, and we have to specify which tangent line we're looking at. We're a tangent line at x equals a, so we plug in a into the derivative function. You can find the slope. Right? So therefore, the equation is going to be simply, right? Remember that it's going to be a y minus y1, which is f of a in this case. So we put the f of a, and then is equal to m. M is f prime of a. Then we're going to multiply by quantity x minus x1. I'm just doing the point slope form. X1 in this case is a. Right? So this is how we come up with an equation of a tangent line. All right, so let's look at this following example here. All right, so let's try to find an equation of the tangent line to the graph of f of x is 1 over x at x equals 2. Right, so let's do that. All right, so we need to find what? We need to find the derivative. So let's find the derivative first. All right, so I'm going to use the definition in this case. All right, I'm going to take the derivative. So f prime, oops, let's see, I'm doing something wrong. All right, so we need to find f prime of, say, x. I'm just going to find the derivative. All right, so remember, definition is limit, right, of f of x. I'm going to write down the definition, f of x plus h. All right, the textbook uses delta x, but I like h, so I'm going to use h. It doesn't cause any problem. All right, and then over h as h approaches 0. Right? So maybe I'll write a note. So here, h is really the same thing as delta x in the textbook. All right, so that's the definition. So since function is f of x, we have limit as h approaches 0, right? F of x plus h. So a function is f of x. So every time we see x, we replace it with x plus h. So this is just going to be 1 over x plus h minus f of x is 1 over x and all over h. All right, then I'm going to combine the numerator, two terms on the numerator. So I'm going to leave the limit alone for now. And here, so we're going to take the common denominator, which is going to be just a product of the denominators. So it's a quantity x plus h times x. All right, so then I will have to multiply the numerator by x. So you have x minus, we have to multiply numerator 1 by x plus h. So we have that. And we still have to divide through by h because you still have h on the bottom. All right, so let's do a little bit of simplification here. All right, so you have h, x minus x cancel out, right? And then you have negative h. Maybe I should, so you have a negative h still left over, right? But we are dividing by h, so you can cancel h here. And then here's a h here, so it gives you 1. Actually, it's going to be negative 1 on top, right? So what you get is, I'm going to go here with a different color. Right, so it's going to be a limit as h approaches 0. All right, so h is gone. So what's left is negative 1 on top. Then you have a quantity x plus h times x. Right? All right, now h is going to 0. So this guy approaches 0. So it basically it disappears. Right? So what's left is going to be, all right, so there's a negative sign, so I put that in front, and a 1 in the denominator, a numerator, and you have x times x, so you have x squared. Right? So we found that the f prime of x is negative 1 over x squared. All right, so let's try to answer this question. All right, so first we have to find a point. So in this case, x1 comma y1, this is going to be, all right, so x1 is given to be 2. So that's that. All right, then we have to put f of 2. So maybe I'll just write that first, f of 2. All right, so that's the original function. So if you plug in 2 for x, you get 1 over 2. Right, so that's easy to find. And then slope m. Right, so remember that this is just ask the derivative and then plug in which x value, which is 2. Right, and we found the derivative to be negative 1 over x squared, so I'm going to put the negative 1 over. X is going to be 2, but you have to square that. So you're going to get negative 1/4. All right, so therefore we have the equation. Right, by point slope form, y minus y1 is 1/2 is equal to, slope is negative 1/4 times quantity x minus x1 is 2. Right, so we have the equation of the tangent line we're looking for. All right, that's it. I hope that this was clear.